Hi everybody, this video is a continuation for your first lesson in mechanics on linear motion. So you've listened to my explanation, so do the other video first, and then I went to school and got the linear motion booklet. So this is your linear motion booklet. I'm actually not teaching in the order in which the notes are written, but I'm teaching you what you're familiar with first and then go on to the new stuff. So once you've listened to my first video, could you please read page 2, the second half of this page, and it is on momentum. So just take a read through this, and if you need to make any more additional notes, do that. Okay, so that's what we're doing. So just that much, this half of this page. And then there are a couple more things that we need to do as part of this lesson. If you turn to page 5, there is a worksheet on impulse. One is for a changing constant force, and the second one's for a changing force, and I'm going to talk you through this one now. And then once we've done that, and lest I forget, there are some questions at the back of this booklet, and on page, again, this is not in the same order as the questions in the booklet, so we're going to go to page 11 first, and we're going to do these questions on impulse because that's what I taught you today. So my first lesson was to do with change in momentum, and those were the questions. So you can do that once we've solved this worksheet on impulse. So I'm going to we're going to do this together, and I'll do it on the whiteboard. I'll talk you through it. So a pool ball of mass 35 grams. So that's the mass of the ball, which is 0.035 kilograms, strikes a stationary ball and is deflected through an angle, and you can see, so it's going straight and it goes deflected through an angle of 90 degrees. The speed before collision is 4.0 meters per second, and it's traveling in this direction to begin with. And after deflection, so the same pool ball is, so this is my V1, initial velocity, and my final velocity is 3.0 meters per second, and it's changed its direction. So the first question is, draw a diagram to show the direction of the force exerted on the moving ball by the stationary ball. Now, the very reason why the moving ball changes direction is that when it strikes the stationary ball exerts a force that causes it to change direction, and that is what happens. Okay, I have my little puppy in the same room. Okay. So in order to find the direction of the force, what we need to do is we have to find the change in momentum, and the direction of the change in momentum is the same as the direction of the force. Okay, so let's get the change in momentum. So our change in momentum is final momentum minus initial momentum. So just getting the change, so, and our final momentum is 0.035 times 3.0. So that's 3 5s are 15, 3 3s are 9, 0.105 kilogram meters per second. And our initial momentum is 0.035 times 4.0, which is 4 5s are 20, 4 3s are 12, 13, 14, 0.140 kilogram meters per second. Now, what I haven't done and what we shouldn't forget is the direction. So final direction is this way, the initial direction is that way. Okay, so in order to get the change in momentum, it's final minus initial. So this is our final direction, which is 0.105 kilogram meters per second. And whenever you subtract a vector, you add the opposite, and the meaning of add the opposite is this is going in this direction, the opposite is 180 degrees opposite, so it's facing the other way. So you go this way, 0.140 kilogram meters per second. And the change in momentum is the hypotenuse of this right angle triangle, and you always draw it from start to finish. So you started there, you're finishing there. That is the direction of the force that is responsible for the direction of the change in momentum. Okay, so we just needed to, this is the first part, A, and calculate the size of this force. So in order to calculate the size of the force, let's first get the size of the change in, calculate the size of the impulse. So this is the direction of the force, but this is also the change in momentum, and your change in momentum is this red vector with the double arrow, which is 0.140 squared plus 0.105 squared, square root. So I'm using Pythagoras, and if I do that, it's 0.140 squared plus 0.105 squared, and I get an answer, shift square root, and I get 0.175 kilogram meters per second. So it's 0.175 kilogram meters per second. That is the unit for momentum, change in momentum. It's got two units because momentum is force times time, change in momentum. So you can also get Newton's second. Okay, if the impact lasts for 0.010 seconds, calculate the average force. So this change in momentum, can you see? Yeah. Change in momentum is also the average force multiplied by the time. So the average force is that 0.175 divided by 0.010. So if I divide the answer that I got by 0.010, I end up with 17.5 newtons. So that's the answer to this one. Okay, now the second one, so you can pause the video there and just do this working. So the second one is to do with a changing force. When you have a changing force, you don't use this formula, but you use the area under the graph line to calculate the change in momentum. So this is the same thing. So you have that, and this is 25 newtons. So this is your force in newtons, and this is your time in seconds, and this is 0.48. This bit is 0.14, 0.18, and that's your 0. Okay, calculate the change in momentum of the ball is the area under this graph. So if you know, this is the shape is that of a trapezium. So the area of a trapezium is half height times sum of parallel sides. If you can't remember that formula, then you just go triangle, rectangle, triangle. So whichever way you do it, you'll get the same answer. So let's say you do it the wrong way. Area 1 plus area 2 plus area 3. So that is the change in momentum. This is that of a triangle. So you just go half base times height plus this is a rectangle. So this is 0.04, this little distance there. 0.04 times 25. So the height is 25 for all of them. And the last one is half. 0.48 minus 0.18 is 0.30 times 25. So you add them all up and you get, so you just go 0.5 times 0.14 times 25. I get 1.75, and 0.04 times 25 is 1.0 plus 0.5 times 0.30 times 25, and I get 3.75, 3, 4, 5, 6.5. So I get 6.50 kilogram meters per second. And again, what is the average force? So change in momentum divided by the total time. So 6.50 divided by 0.48, which is the total time. I end up with 7.81 newtons. Okay, so that's how you do these questions. If it's just so reiterating, if the force is constant, then you can use the formula. But if the force is changing, then you can get the average force. If you get the change in momentum from the area under the graph divided by total time. Once you've done this, just a reminder again, we are solving, there are 6 questions on impulse, which I'd like you to do. So bye for now.